equations in our chapters, but basically this is a very simple, straightforward application. We good? Okay. So now we're back to here. So this is an example here. We like to find out the time of flight. So here we can exercise. Basically, this equation is what we done in the previous sections. So simply here we figure out the individual parameters here. So to get those things done, then we need to fix the first one. What is the value of the A? The A in our example is R divided by 2 minus Q, and we have the information at the burnout. So we can pick it up at the burnout. RBO and will be equal to, what is RBO? So this is the Earth, and this is the burnout. And that is this is our RBO. So from here you can see its burnout happened at the altitude, how much? 150. Here is 150 nautical miles. So therefore here RBO is equal to the Earth's radius equal to 3443.9. This one. So let me convert it into DU. So that will be equal to 1 plus 150, 3443.9, and this is in DU. Okay. And at the burnout, the BO equal to 0.8 we are given. So basically here we can calculate it, that one equal to 0.89 at 96 DU. And the next one, we want to determine E. The E is the eccentricity, and that number, the formula is this 1 plus Q, and Q minus 2 times cosine squared times phi. Phi is the flight path angle. And again, here we have information available at the burnout. So here we can pick out the information at the burnout there. So now again at the burnout we know the Q equal to 0.8 and BO. And what is VBO? Again, for this case, the Q equal to 0.8, which is less than 1. So from the beginning of our lecture today, we simply talk about the situations of this equation. Again, let me write it out, these equations. Sine 2 VBO plus V over 2 and equal to Q, what's that equations? 2 minus QBO and QBO and sine V over 2. I feel a little bit dizzy now, too excited. Okay, and from the beginning of the lecture today, we talk about this condition, this equation for the Q is less than 1, and we're using the example Q equal to 0.8. So refer to our earlier discussions. Okay, and that exactly is our lecture note. And right now you can see we want to determine, our earlier discussion is this. Let me summarize here. Summarize below. Let me do that quickly. I can do it. When this one is less than maximum, equal to 1.46 radian, and VBO is equal to certain numbers there. Certain numbers, VBO equal to pi 1 over 2 and pi over 2 minus this one. Okay, so when, sorry, this is equal. Then VBO has two values, and VBO1 and VBO2, and I would say see the solutions, see the formulas. Okay, to save time. So now again, you can see for determining what is this value, and right now that is fitting into these situations for Q is less than 1. Okay, right now we have for Q less than 1, we have this situation, then we have the whole things. So right now for our condition here, our Q is less than 1. So we're going to check. To check which value of the VBO will be go after, really it depends on the value of the psi, right? So now we check here for our problem, what is psi? So let me draw this one again. So this is a free flight. And this is the power flight here. So this is the power flight. So that this meaning is this. And this is the R free flight. And this small range corresponding to the first stage. The first stage is the power flight. So this smaller range is called the R hours, the power flight range. And this range corresponding is a re-entry, and that's called the re-entry. So from here you can see the RT equal to RP plus RFF plus R re-entry. So therefore you can calculate RFF equal to how much? The 4700 minus 45 minus 155. So that is 4500. Okay, so you have the RFF, so therefore GFF equal to RFF divided by radius of the Earth, 4500 divided by 3443.9. Okay, so that number is equal to, do I have that one? So that is 1.3067 radian. For this province, the flight range angle is that value, and we check against the situations which condition would be this one. Are we good? Everyone follow me? A little bit too fast? If too fast, then watch the video again when you're back later. Okay. So with these situations, then we can determine VBO. And VBO, again, using the two equations, then we have two values, and one value will be equal to 38.4 degrees. The other value is 14.16 degrees. Okay, we have two possible values, and again, we have two formulas, right? Okay, you plug in there. And so in this way, this situation, for this problem, we have two solutions. And for the remaining, let me go the solution for this option. Say, go to 38.4 degrees. So with these options, then this number will be equal to 0.6407. So again, continue to here with the psi equal to 1.3067, then we can have the E1. Again, the E1 is a formula there, and at the rate plugging, so the E1 will be equal to 108.19 degrees, and that is 1.888 radian. So therefore, we have everything ready. We have, for this formula, we have A, and we have E, and we have eccentricity. So therefore, the time of flight for this problem is 3.02 TU. And for your reference, if you like to practice, for VBO equal to 14.16 degrees, then time of flight will be corresponding is 1.808, 1.808 TU. This number about 32 minutes, this number about 24 minutes. Be good? A bonus questions and turn off.